So this is the spreadsheet that we're going to be using with Excel Link. Crucially, all of the information is found from cell A1 all the way down to the bottom right here in cell K9 is content which will be read by the Excel link. Anything outside of that will not be read by the link. All that's happening here is that we're applying design variations in the same manner that they were exported, but we're changing the values to get it to create new variations. The way that it creates new variations is that we change the cells that are in the B column here to -1. So anything with -1 is a brand new design variation. So the danger is that you keep running Excel Link and you've got this spreadsheet with all the same content in it, you will end up with duplicate design variation entries happening. So it's just important that you're aware of that. All we've done is automate some of the process. So for example, the start chainage, rather than us manually typing in all the chainages as we've maybe done picking through the design variation form, we're actually automating it using cells over here. So if I type in a new start chainage of 100 for my driveway, all of those chainages get updated all the way through, including updating the footpath, simply using the taper 1 wing width and the taper 2 wing width and the driveway width. So if I decide that my driveway widths, the wings need to be 0.9 at one end, 0.9 at the other, you can see how all of those chainages are updated. Now we're going to leave that as 1, and 1 obviously requires you to know your taper or wing widths and your driveway widths. The codes, this is really optional stuff, but all it means is that if you type in your codes here, rather than you manually going and replacing LTK, for example, with RTK all the way through that, and yes, there's only 3 entries, we've saved a bit of time here by ensuring that basically the cell is being read here. So it's reading the cell N6, which is here. I'm just going to go in and make that change here. You can see how they all get updated. Same goes with the footpath code. We'll leave those as L for the time being, making sure that the LTK code gets updated. You would obviously make sure that if you've got slightly different code names, that you ensure that those are put in there. Underneath, all of the values that are being shown in here are in relation to the width and vertical change that are made to the code when we apply the variation. 0 means set. 1 would mean incremental, so you can see all of the values are being set exactly like we did in the other video. The image down the bottom is to help you guys complete these cells. So these cells are automatically updated with values that you pop in here. So for example, the TK code width is being set by cell A1 here, so I know that that's 150 mil. The BK code width here I know is 150 mil for our standard kerb. When it gets to the layback, however, I decide, well, actually the TK code here, yes, could be 30 mil. For cell A2, that could be 30 mil, but it could also be 0, which is what we're going to leave it at. So you're basically setting up your kerb shape and your layback shape, and all of those value changes are being updated and assigned in this for you. Now the footpath is optional. If you don't want to make a footpath adjustment, all you need to do is basically put 0 in these cells. 0 means that no variation is going to be added. If you do want the footpath adjustment to be made, then you basically tell it the current footpath location, which in our case is 1 meter away, which is this FP1, at 5%, which is this FP1%. You then input the new width, which in this case would be 700 mil, and the new slope, which is 17.1. So the software will go ahead and add 3 entries, 3 variations, exactly in the same manner that we did. Let's now have a look at how this is applied using Excel Link.